Hey, what is up guys? My name is The Cherno. Welcome back to another Patreon exclusive video. Today we're going to be taking a look at something that is hopefully pretty exciting for you guys to actually take a look at. Every time I make these kind of exclusive videos, I always try and show you guys, I guess, what I'm working on that I'm not really sharing with YouTube yet. Something a little bit more exclusive, as just a little thank you, of course, to supporting everything that I'm doing. So today we're going to be taking a look at Vulkan. Now, I'll be honest, I think I'm about 3 days into this. Basically what I decided to do, and I'll kind of go through these phases where I kind of, I'll just randomly wake up one morning and be like, you know what, I just want to jam this in. And it'll be like, you know, usually something pretty heavy, something that will be quite time consuming, not something typically too easy. And so over the last 3 days, actually, and I guess I'll try and share my journey as well as kind of showing you guys the result throughout these videos, because I know that a lot of you have been asking for me to share my process a little bit more, and that's actually something that I want to get into YouTube videos as well eventually. But anyway, long story short, on like Saturday afternoon or whatever, or morning or whatever, I think I had like a fairly large block of time. And I mean, I've been trying not to work on weekends because now that YouTube is my full-time job, there's a lot of working going on, and you know, it's not great for my personal life, nor for my wife, nor for, you know, my, I guess, mental state as well. Just constantly kind of working, constantly, you know, kind of having my mind in YouTube stuff and programming and all of that stuff. Not that I have been programming much. It's been mostly like YouTube planning, like for videos and stuff like that. But I finally decided, you know what, I've got Saturday now. It's like the weekend, and my wife happened to be at work Saturday morning, and I just thought, you know what, I haven't done any programming in a while. I want to jump in and see if I can just jam Vulkan into Hazel as soon as possible, like just as quickly as possible. And that's kind of what I did. And then I really quite enjoyed working on that. And so I kind of spent a few more days, I think. So today's Tuesday. So a little bit of Sunday, and then pretty much all of Monday, which is like a work day. And like all of today, it's like 4:30 p.m. on a Tuesday right now, just basically getting Vulkan into Hazel. And this is, of course, something that I've been wanting to do for a while now. Hazel, of course, is supposed to support, well, is going to support like every rendering API out there. Well, at a minimum, at least, like the ones in the close future should be like OpenGL, Vulkan, and DirectX, probably like 11 and 12 eventually. And then like maybe further down the line, probably I'll add Metal. But that's kind of last on the list just because it's kind of a narrow target. But anyway, the point is, Vulkan was always going to happen. And, you know, I had to kind of make this decision of how I'm going to structure the entire renderer in Hazel and the whole rendering API in Hazel. And that's kind of a difficult thing to do because, you know, like, I mean, I know how Vulkan works. Like, I know how DirectX works. You know, I've had all this kind of experience of working like on Frostbite and, you know, the mobile engine that we did before that, which is called Osiris. You know, I've been exposed to all of those APIs, and I've written a little bit of code for all of the APIs. So I kind of loosely know how they work, but of course that's very different than actually sitting down and being like, all right, you know, let's write a Vulkan renderer, because Vulkan is so complicated that I don't think anyone can kind of just sit down at a desk and just write a Vulkan renderer. Like, they'll need a lot of references. And I guess that's kind of like different because in OpenGL, like I could sit down and I could write an OpenGL renderer for you, possibly even on paper with no API reference whatsoever, just because there's not that much code there and I've had a lot of experience with it. But Vulkan's very different. And so what I decided to do one day, and this Patreon exclusive video is becoming story time with Cherno. So let me know if you guys want this and if this is fine, or if you want me to show you more code and let's talk. Because I was planning on kind of showing you guys the code, but then I thought, you know what, I'll explain my process and how this came about as well. So anyway, the point is that I knew that Vulkan was going to take a lot of time because it's very, very verbose. It's probably the most verbose API. I'm pretty sure it's even more verbose than DirectX 12. And so because of that, like I was kind of, not that I was putting it off because I really wanted to dive into it, but I just suddenly realized that, okay, we're getting up to the point where I need to make some serious design decisions as to how things are going to get rendered in OpenGL. And I know that Vulkan is going to influence that because I need to abstract my render API in a way that supports, you know, Vulkan and OpenGL, and then DirectX and everything else. And so that was, you know, in order to do that, I guess my process, you know, would have to be something like, you know, I've got a basic, let's just say 2D renderer up and running in Hazel. Right now, I need to take that and implement it in Vulkan. And, you know, with as little abstraction as possible, probably. And then I need to start abstracting it out and seeing all of the dynamic parts of Vulkan, stuff that isn't boilerplate code, essentially, stuff that has to change based on what kind of render pass I'm doing or something like that, right? And then you kind of take that out, and then you end up with these kind of abstracted API classes. That's usually my process. And again, I probably will talk more in depth about that in the future, in like a YouTube video or like here as well. Like with these Patreon exclusive videos, like if you guys leave comments requesting something, usually I'll get around to that, because I don't think many people do that. I think a lot of people just rock up, watch these videos, and that's it. So if you do have a concrete question that you want me to actually talk about, something that you want me to talk about or show, just write a comment, and then hopefully I'll be able to get to that, because, you know, that's kind of the whole point of this Patreon interaction, something a little bit more closer than what you see on YouTube. Anyway, so that's kind of the idea. And then I wound up with this. So let me just show you what I've got, I guess. Basically, this is all client-side code. So if we take a look at this, you know, we've got Sandbox app. I added this new renderer test layer, which we'll get to in the future. Well, in this video, but in a minute. And then ignore this empty layer, which is just literally an empty layer. And then this is like basically the stuff in the, I should mention that this is the public Hazel code repository. So I took the public Hazel code repository and I added Vulkan to that. I did not do it to the Hazel development branch. The reason being that is a lot more complicated. And for me to put Vulkan into that would have been just it's a lot heavier. Whereas with the Hazel public branch, you know, that just has the beginnings of a very basic 2D renderer. And I thought that would be a perfect candidate for just jamming in that abstraction and working in Vulkan in there. So that's what I've done. So this is the public repository, and this is the Sandbox app file in the public repository. And so what I've done is literally, so I'm just pushing a different layer here because I wanted to specifically test, I wanted to create a test layer, of course, to kind of test this out first as I was developing this and adding Vulkan support. And then what you'll notice is before we return new Sandbox, we basically just set the API. So this is all runtime. You know, it was always going to be like this. I don't particularly like deciding the rendering API at compile time. And obviously the way that we've structured or everything, right? The way that we structured all of these render API classes throughout this entire series, throughout the entire game engine series, was to support runtime switching, essentially, or runtime selection. So before you create an app, what you do is you set your API to a specific API. So in this case, it's set to OpenGL. And that's it. If I change this to Vulkan, it will theoretically run exactly the same, but using Vulkan. So if I just launch it with OpenGL to begin with, this is the little test scene. So what we have here is a bunch of quads being rendered. They're all batched together into a single draw call. The color is being pulled in as a vertex color, and it's just kind of set. You can see that there's kind of this gradient going on because basically the color for the red and green channels is just set based on its horizontal and vertical position respectively. So in other words, it kind of almost looks like a texture coordinate, but yeah, and blue is set to like 0.5. If blue wasn't set at all, it would literally be like a texture coordinate. But basically we have like from 0 to 1 on red, I think, and then from 0 to 1 on green vertically. And then just blue is set to 0.5, I think, for everything, which is why we kind of get this color. And then we have just a textured quad here, which is showing the checkerboard texture. And then I've also set its, the actual PNG file has an alpha value. Every pixel has an alpha value, I think, of 0.75. So it's partially transparent, which was kind of just to test blending, I guess, and make sure that that was working. So that's what we have here. And then we have the standard kind of camera that we have. And then, you know, this obviously resizing works, and resizing works. That doesn't, no, we did make that work in the public repository. I forgot about that. Yeah, so anyway, the point is that's kind of our test case. And then of course, if I close this, and then I I change this to Vulkan and I run it, then hopefully this will run fine. Okay, and you can see up here it says Vulkan, and you know, we've even got some Vulkan stats here, such as that we're allocating certain buffers. Yeah, that's kind of, and actually it runs a lot faster or smoother. I think that the reason for that is that you can see that this swap interval, so in other words, vsync, is not doesn't work if you're not using OpenGL with GLFW. And I am still using GLFW for Vulkan here. So that's kind of that. And you can see you can resize it and everything is great. So this is obviously looks identical, which is the entire point. So yeah, that's basically what I've done over the last like 3 or 4 days. I've basically taken the Hazel public branch and then just added Vulkan to it. So now the part that everyone wants to see, and then yeah, there's some exit stuff that needs to be cleaned up, of course. Only a few days in. Okay, so let's take a look at this. Render a test layer is basically, you can see that that's what I'm pushing on here. This is actually what's being run. And this is something that is client side, of course. So this is inside our sandbox project. And there's obviously absolutely no render API specific code in sandbox. So there can't be, because Vulkan and OpenGL kind of header files are never included. So there's quite a few things that have changed in terms of structure. And this video is going to be an hour long if I actually detail everything that I've done, because there was a lot of work that I did, obviously, and a lot of restructuring. But, a lot of it was kind of, I guess, the same, just in a way, like there wasn't really anything too different than what I, in my head, already planned for Hazel. So I don't think that there were massive API differences. Oh, by the way, the only time that any kind of client code has to decide between Vulkan and OpenGL or anything like that is shaders, just because at the moment I don't have a central shader system. So in other words, Vulkan, I'm loading these SPIR-V shaders into Vulkan, and then into OpenGL, I'm just loading in that text shader where the fragment and the vertex shader is in one file, just like it is in the game engine series. So in the future, this will be changed because everything will be compiled with SPIR-V. We'll write a single shader, and then we'll use basically cross compilation to compile that into every render API that we need. So shaders for OpenGL, shaders for Vulkan, shaders for DirectX, and shaders for Metal. Now, I haven't decided yet if I want to make it so that people can write Hazel shaders in in GLSL or HLSL. I'm quite a big fan of HLSL. But now that GLSL is very explicit with bindings and things like that, I think I still prefer HLSL, but I might keep it as GLSL just because I feel like people are more familiar with that. At least people watching the series. So anyway, but for now there, as you can see, there's a bit of a branch here. Okay, so to render what you see there. Now this renderer test layer is not the 2D renderer, right? We have this renderer 2D thing. That's actually the 2D renderer. All this test layer is doing is basically manually rendering that checkerboard texture. So that's actually what the layer is doing. So in other words, if I just go, and this is the renderer 2D, this is where I'm actually batching together all those quads. You can see that here. If I was to like comment that out, for example, and I hope this will even work, but it should, I guess. If I were to comment all of that out, then the only thing that the layer is doing is showing that checkerboard texture. And you can see that did not work. Oh, that's because of the texture. I don't even know why that didn't work. I would have expected that to totally work. Flush might be doing something important. Anyway, early days, obviously. So yeah, you guys get to witness all of these failures. So yeah, okay, well there it is. I'm not sure why, and we do get a bunch of errors, so it's going. Command buffer is already in use. Okay, anyway, the point is, this is still a little bit finicky as you can see, but there's everything except for the kind of everything happening in the background. So obviously that shouldn't be the case. It shouldn't be reliant on that 2D renderer. I don't even know what that 2D renderer is doing. It might be like begin scene and end scene might be doing fairly vital parts. I don't think so though. So I am quite surprised that it's not working. Anyway, it doesn't matter. The point is that all that's happening here inside this test layer is just that checkerboard texture. And then of course the 2D renderer, we begin a scene with a camera, we draw all the quads here with varying colors, and you can see there's that kind of color that's happening over here. And then we're basically, that's it. And then we end scene. And then that's drawing a whole bunch of these quads. And then once we've done that, we want to basically draw the vertex buffer and the index buffer, which is holding that checkerboard texture quad. So there it is, the vertex buffer and index buffer. This is the vertex buffer just here with the positions, texture coordinates, and colors. The color is there. Obviously, the color isn't used at the moment because it's using the texture. And then that's, of course, the camera, again, is being set into the uniform buffer, and then it's being submitted for rendering. Okay, so that's basically the kind of renderer test layer in a nutshell. That's how everything works. So as for the kind of client-side code that needs to be written to render that kind of stuff, well, basically what we've got here is, I think, the only thing that's really changed, well, there's a few differences, obviously, but I think the biggest difference is this kind of introduction of a pipeline. Now, this was something that was going to come into Hazel eventually anyway. I mean, even if I was writing an OpenGL only renderer, I'd probably write a pipeline abstraction just because it makes a lot of sense. But basically, you know, the pipeline is, in a way, it basically ties together a few important elements that both DirectX and Vulkan actually need, such as basically the shader and the vertex buffer layout. Those two usually live together. The fact that they don't in OpenGL is a little bit odd, because the vertex buffer layout is something that kind of lives in the vertex array in OpenGL. And then the shader is just completely free floating, which is a bit odd because it's not really how any other API works. But anyway, so what this pipeline does is basically you create a pipeline specification first, and a pipeline specification. This is a very kind of common pattern that I've been using. You know, we have this like specification, and then we have the actual pipeline. Same with render passes. So render passes, we have a render pass specification, which is very bland at the moment, and then a render pass. You know, with frame buffer, same thing. We have a frame buffer specification, and then the frame buffer. So basically, what ends up happening for a lot of these things is that these classes, these abstract classes, because they're implemented by the actual render API, they're just like containers of data that is abstract, such as clear color, right? Does not obviously depend on any kind of rendering API. It's just a clear color. And that's kind of it. And so this is an object that is specified by the client, usually. One can be specified by Hazel if it's like an internal feature or something like that. And then ultimately, eventually, some actual like renderer will read that data and do something with it. And that's kind of a little bit different than what I've been doing thus far with OpenGL, because, well, primarily because I wanted to show, I mean, you guys know me. I like to kind of start off with the simple way of doing things, to both make the series easier to consume for everyone and easier to follow along with, and just, you know, just be easier in the beginning. And then also just to show a particular way of doing something. And then I'll usually like switch it over and be like, okay, now that we've done this, we've done the easy way, let's take a look at the actual proper way to do this, or the harder way to do this, but that it'll be more powerful. So that's, obviously I like doing that. And that's kind of what I've done. You know, if you look at like, I don't know, an OpenGL texture, for example, like OpenGL texture handles its own binding. It has a bind function. Same with like GL buffer, for example. You know, OpenGL buffer binds itself. Element array buffer for index buffer and array buffer for vertex buffer. That's one way of doing things, and that's fantastic. And that's what I would do probably if I was doing an OpenGL renderer. But when you start abstracting this out and you start dealing with many different APIs, what you'll find is that usually you want to ultimately, you know, buffer creation and like initialization code and buffer utility code, such as, you know, mapping, unmapping, which I think map and unmap in this case literally just do a buffer subdata because that's faster than actually using glmap buffer. But anyway, that's that kind of utility function, right? That stuff is what you would have in your render API specific kind of classes. But actual things like, okay, I now want to render a quad. What do I have to do? I have to bind this, I have to bind that, I have to connect these. You know, that is much more render API specific, which is why I usually would take that stuff and actually do it in another class that just reads this data, if that makes sense. So a really good example is, because OpenGL is really simple, right? You know, if we take a look at what the 2D renderer is doing, you know, it's specifying its pipeline specification. Here's for Vulkan, we have these spur V shaders. For OpenGL, we have the GLSL shader. We have this vertex buffer layout, which is the same as the other kind of checkerboard texture one. Then we have begin scene, and begin scene, of course, maps the buffer, resets the pointer to that buffer, sets up the camera, right? So by setting up the uniform, I don't know why transform is here, that's not really used. But anyway, sets that up, and then we go into, you know, the actual draw quad, which just literally copies data to that buffer. And then we have end scene, which calculates the size and unmaps it. Unmap will actually do the upload to the shader. In Vulkan's case, you don't really need to do that, especially if it's persistently mapped. But it's not in this case. It actually does an unmap and a copy. And then submit actually submits this. Now that we have this, using the pipeline, the vertex buffer, and index count, basically says that I'm going to submit this for rendering. And then when flush happens, and yes, I guess flush was important. That's why the other thing didn't work. When flush happens, that is at which stage we actually go through that renderer queue and we process all the commands. So how does that work? Well, let's consider the OpenGL case first because that's super simple. So renderer submit. Well, let's take a look at renderer submit. So that just basically says, where's the render command buffer? I'm going to submit this into it for rendering. A submission is basically like a renderer submission. Or a render submission rather. So render command buffer. So GL render command buffer. So what that does is pretty simple. So when we begin a render pass, and this is important because there's also render passes, but anyway, we're not going to get to anything. We're not going to get to everything in this video. So, you know, I mean, in OpenGL, you can see a render pass submission just clears the color. And if we would have actual like render targets that weren't the screen, that's where you would bind them and do all of that stuff. And you would probably unbind them, but we're only rendering to the screen at this point, so it's nice and simple. And then submit, you can see, basically goes through and it gets all the information it needs. So pipeline shader, and this is all in OpenGL specific land. It gets the pipeline shader, vertex buffer, index buffer stuff. We bind the shader. In this case, we actually set the texture, and the shader has textures, and this is a little bit odd. The reason it's written this way at the moment is because I haven't found a better way to do this using Vulkan yet, because in Vulkan, like the shader binding kind of gets tied together. So in other words, shaders and textures in a way get tied together. So I don't know how I'm going to handle that. And it's just like basically how descriptor sets work in Vulkan, but we'll see. So for now it's a bit odd, but it won't be like this in the future. We bind the vertex array, which is part of the pipeline at this point. We bind the vertex buffer. We set the layout, which is fortunately something we have to do because I don't like well, we're not going to use vertex arrays in OpenGL basically because nothing else uses them. It's a bit weird. And by nothing else, I just mean other APIs don't really have an equivalent. And I've mentioned that in that vertex array video. So that's why we kind of just bind a vertex array, but we still have to set the layout. Then we bind the index buffer, and then we do our draw call. Right, that's what happens. Now that gets queued. You can see it's a lambda, gets pushed back into a queue. And then when the flush happens, that's when it goes through and it does all this. Really simple, okay? That's what happens. Now, the Vulkan render command buffer, a little bit more complicated. So for example, begin render pass in Vulkan actually does a begin render pass, right? And then, you know, submit actually, you know, sets up like the viewport and all of that stuff. It binds like the shader descriptor sets. It binds the pipeline, which is an actual pipeline, not just an abstraction over that, which is what it's used in OpenGL. You know, we bind our vertex buffer, index buffer, and then we actually have the draw call here. And then flush basically does the same thing. But of course, Vulkan has its own command buffer and its own command queues. So what happens and what's different here is that flush, instead of actually doing immediate mode rendering, which is what this does, because this actually executes the function and then this goes through the queue, and then we'll eventually actually do the draw call. This just basically begins a command buffer, executes all of the stuff that's been submitted to the queue. So for example, this, and then first you would begin your render pass, then you would do the rendering and bind everything, and then you would end your render pass. And that's what happens inside this kind of for loop. And then you end it. And that's kind of it. And at the moment, you basically only get one render pass because, well, which makes sense because the render pass actually clears the buffer. So in the future, if you were to do multiple render passes, I guess you would either not clear your frame buffer or you would actually bind a different frame buffer. So anyway, there's a few things that still are a bit finicky and need figuring out, but that's basically the gist of it. And you can see that, I mean, if we look at anything really, if we look at like Vulkan buffer, for example, so a lot of this code, by the way, is, so where I got this code from. So basically a lot, like the two main resources I used were, and I'll try and bring them up here. So there's obviously, and I'm sure everyone who's done any kind of Vulkan is aware of this, but Sasha Willems is this lovely chap who has basically made every single, who has this incredibly useful library of Vulkan examples that are pretty well made. They're quite optimal, like there's nothing, like in terms of correct usage of Vulkan, I think people trust him a lot. You can see there's a lot of examples, right? And there are a lot of really cool ones. So this was like, I would say the primary resource that I used, just because like for me, it's really easy to just like take this, clone this, and then run a particular example and then dissect it. And then for example, his triangle example does everything with very little abstraction, like basically no abstraction. So it's later abstracted, but it's not in that example. So if you start there, it's good. And then obviously, like I've looked through like all of these and they're all really good. And I think it's important to look through all of them, because if you start with like triangle and then pipelines maybe, and that's it, and then you're just like, okay, that's how Vulkan works, that's bad, because in the real world or in more complex drawings, it works very differently. Yeah, and there's a lot of really, really cool stuff here. That I would definitely recommend that you check out if you're interested in Vulkan. And then the other one that I used quite a lot as well, but more of like as a reference when I didn't understand certain things, is vulkantutorial.com. And vulkantutorial.com, there's a nice little ebook that you can download, which you can then like either print or read as a PDF. That's super, super useful. But anyway, the point is, you know, if there was anything that I didn't like understand, like for example, what is a descriptor set? What is a descriptor set pool or whatever? You know, that kind of stuff. You know, why do we need an image view or whatever? You know, I would look it up here. And well, I guess the third reference that I didn't really mention, because it's probably not that important, is the fact that like obviously I've, you know, been exposed to Vulkan as of like basically before it was released when I was working at EA. So that's kind of like, I guess, just stuff in the back of my head of like knowing, for example, that, you know, if you want to make a texture in Vulkan, you know, you have your samplers, you have your image views into that texture, you can't access it directly, or things like staging buffers. You know, that kind of stuff is something that I've just in general been exposed to for a while now. So I guess I just kind of, you know, when I read that, I'm like, yeah, well, obviously that's how they're doing it. But I guess if I had no knowledge of that coming into this, would be a lot harder. Anyway, so those are the two those are the two references. You know, if you take a look at, there's also Vulkan, what was it? The swap chain. Swap chain. This is basically a copy of what is in that repository at the moment. I'm obviously going to need to change it because it has to be somewhat dynamic. But swap chain is something that is fairly boilerplate code. So in other words, you kind of just set it up and you forget about it. So this is basically, you know, this code is basically just from here. It's from like examples base, I guess, or Vulkan example base, or what's it called? There's like a base library here. Sorry, a base project. Maybe it's just base. Yeah, here it is. So he's abstracted it his way. I've obviously abstracted it my way. But I think Vulkan example base, which is this, you know, that has like a whole bunch of code that, you know, does a lot of stuff. You can see it's like 2,200 lines of code. Then there's also, what was it? You know, the device abstraction. There's a swap chain somewhere here. Yeah, swap chain. So that's basically where a lot of that code is from. It's obviously quite different in my repository because I've changed it a lot and I've just made it more what I want, but a lot of the actual Vulkan code with the comments is directly from there. You can see there's even commented out stuff that is specific to his API. So anyway, that's where I've kind of set that up. But then of course I've really massively reorganized it and abstracted it kind of my way. So that's what I've been doing the last few days. Let me know if you guys enjoyed this kind of video. If you want me to dive down a lot deeper into Vulkan and explain a few things that I've done, obviously this is fairly early days. Yeah, it's once I get like a PBR scene up and running, for example, and integrate Vulkan into Hazel Dev, I'm sure things will change. And I'm sure I will be a lot smarter when it comes to Vulkan. Because this is probably the first time I've actually sat down and written a Vulkan render. I mean, I did like a little one that was standalone, but integrating into a game engine like Vulkan, this is like outside of like EA, this is like the first time I've actually done this. So it felt good to finally get it done. It was relatively painless, to be honest. Back when I worked on Vulkan 3 years ago, and the drivers were very annoying, and I was also having to deal with Android when it came to Vulkan, because we were trying to ship Need for Speed No Limits on Android with Vulkan support. That was like quite a lot of headaches for the whole team there. But I think these days, like, I'm like really happy with Vulkan. I mean, it tells you, the validation layers tell you as soon as you're doing anything wrong. Obviously, it expects that you kind of understand how Vulkan works, which I think is not that complicated when you break it down. It's incredibly verbose, and things like the swap chain and having to set that stuff up manually. Once you get like the swap chain set up, and I guess all the kind of just main kind of boilerplate setup, things like queue families, you set up your queue family, you set up your queue, your main command buffer, all of that stuff. Once you get that up and running, which admittedly is probably half the work, the rest of it, actually like drawing and creating vertex buffers, doing all that stuff is relatively painless. And it's quite low level. It's quite exciting, I think. I quite like it. I'm interested to maybe once I get something a little bit better. So at the moment, I mean, look, we've got pretty much everything we need, I guess. I want to fix my texture abstraction a little bit, but we basically got everything we need. Like we've got textures, we've got, I can do like shaders, I can do uniform buffers, I can do a lot of things. Probably need to switch OpenGL to using uniform buffers as well. That's relatively easy to do, of course. But ultimately we've got everything we need. I could probably render a 3D scene here using this existing code. So once I do that and I set up like a nice cube that's lit by some light or whatever, and we have a 3D scene where we can move the camera around, I want to maybe implement DirectX 11 probably, and then 12 maybe. I'll see how I go with that, because obviously I don't want to spend all my life just integrating APIs into and rendering APIs into Hazel. I want to actually make something with Hazel. But oh my gosh, this has been going for 32 minutes. I can't believe that. Okay, anyway, hopefully you guys enjoyed this very long video. I would keep going. I can't believe this time just flew by. I thought it was like 22 minutes. Anyway, hopefully that was somewhat helpful to you guys and wasn't just me rambling about this stuff, because this is obviously completely unscripted, completely raw. Yeah, let me know what you think. I will probably, I'll probably keep working on this until I have like a 3D scene like I wanted. And again, this is just the raw kind of Hazel branch. You can see we have platform OpenGL, so that's all the OpenGL stuff, and then Vulkan, and then that's all the Vulkan stuff that I've made. So that's kind of, I guess, how everything is put together. If you guys want access to this code, let me know as well, because obviously this isn't the Hazel Dev repository, so therefore you don't have access to this, but I can set up another repository potentially, and clean this code up and show you guys, I guess, the more or less, not just Hazel Dev branch, which is like, the actual Hazel game engine stuff, and, dealing with OpenGL and extending that into like PBR rendering and making a level editor, which is basically what I'm doing on that branch. This is more like implementing kind of backend stuff like rendering APIs. So if you want to see this as well and you want access to this, let me know. I'll set up another GitHub repository and give you access to that. Other than that, yeah, let me know what you think of this type of video, and if you want to see more, and if you have specific questions, then go ahead and ask them, and I will see you guys next time. Thank you, of course, for your support. Goodbye.